Alright, so this next video will be about how we can actually apply solving quadratic equations to a particular situation. And so for this example, we see that we're trying to find the points of intersection on the graph of these two functions. So kind of give you an idea of what's going on so that you can have a visual. We have a function f of x, which is negative 5x plus 11. And so that function will look something like an upside down parabola. And then we have another function, 12x plus 15, which looks like a line with a positive slope. So we have something like that going on. And so here, the points of intersection will be here and here. And so we're trying to find the x coordinates. So let's say if we had x and y axes here, we're trying to find the x values where these two functions intersect one another. So that's sort of the visual that's going on. Now we know that whenever we have two functions that are intersecting each other, they are equal at those particular points. So in other words, they share the same point. So what we would do in this case is we would take f of x and we would set it equal to g of x and then just solve for x. So I'm going to go ahead and clear this and go ahead and do that now. So we're here and we'll just set f of x equal to g of x. And so that would be minus 5x plus 11 is equal to 12x plus 15. And so at this point we realize that we have a quadratic equation because the exponent is the highest exponent that we have is a 2. But we need to have everything on one side and have the other side equal 0. So we're going to subtract 12x from both sides and subtract 15 from both sides. So we're going to have minus 12x minus 15. Of course, these cancel to 0. And here, these are two unlike terms. So we'll just go ahead and write those out. And then 11 minus 15 is going to be negative 4. Okay. Now to make life a little bit more simple for us, we'll go ahead and multiply both sides by a negative 1 to get rid of all these negatives here. And so now we're at this point. So now that we're here, we have a quadratic equation. And so if you watch my other videos, you know that we can either try to factor, or we could do completing the square, or we could do the quadratic formula. So for this case, I'm going to start off answering this by just doing factoring by trial and error method because it's relatively easy to do here. But then I'm going to come back and do this solve this particular equation again by doing the quadratic formula so that I could showcase that. So here, if we do it by trial and error, we know that we have these two things here. Since we have plus and plus, we're going to have plus and plus there. Since our leading term here has a odd leading coefficient, we know that we can just write this as 5x and x here. And of course, if we put a 2 and a 2 there, because 2 times 2 is 4, and you see that whenever we multiply a negative 5x times 2, we get 10x, and a 2 times x, which is 2x. And if we add both of those together, 10x and 2x, we get a positive 12x, which is what we need. So at this point, we know that 5x plus 2 is equal to 0, or x plus 2 is equal to 0. And if we go ahead and solve, subtract both sides by 2, and then divide by 5, we get x is a negative 2/5. And over here we get, if we subtract 2 from both sides, x is negative 2. So the two places on the graph of these two functions where they intersect would be when x is negative 2/5 and when x is negative 2. So somewhat relatively close to one another. All right, so now what I'm going to do is clear all this information up and have our equation again and show you how we would do this, solve this particular quadratic equation, which gives us the same answers, but doing it by using the quadratic formula. All right, so I've cleared out some room so that we can solve this problem by using the quadratic formula. If you notice here, the quadratic formula is written above, and so this x with the subscript 1 and 2 just basically means that we're expecting up to 2 solutions. The a, b, and c that you see here, no pun intended, is from our quadratic function being written in this form. Okay, but the a, b, and c that are here are the same a, b, and c's that you see here. So just to know, all we have to do is just do plug and play from that point, and we're pretty much good to go. So if we have our equation here and we go ahead and solve that, we know that in this case our a is going to be 5, our b is going to be 12, our c is going to be 4. So we just go and plug all that stuff in. So we'll just say x 1, 2 minus b, which is going to be 12, plus or minus, and then b, which is 12 squared, minus 4a, which is 5, and c, which is 4. And thought I was going good there without messing up some 4s. See that went away quickly. All right, so here, and all of that over 2 times a, which is 5. Okay. So now from here is pretty much just number crunch. So we have minus 12 plus or minus 12 squared is 144. And then we have 4 times 5 is 20. And 20 times 4 is 8. Okay. So now we come here. And all that divided by 10. If we do 44, this is 144 minus 80, that should be, if I'm not mistaken, 20, then so it should be 64. So we have negative 12 plus or minus square root of 64 divided by 10. And of course, square root of 64 is 8. So we will have negative 12 plus or minus 8 divided by 10. So at this point, we could go ahead and add our answers. So if we did the first one, we would see we have negative 12 plus 8. That would give us a negative 4 divided by 10. So I guess I messed up 4 again. So we have a negative 4 divided by 10. And then the second answer would be a negative 12 minus 8, which would be a negative 20 divided by 10. And of course, if we simplify negative 4 over 10, that would be a negative 2 divided by 5. And if we simplify negative 20 divided by 10, that would be the negative 2 that we found. So here we see that either way, we get the same answer. So we're going to plug this in. This would be a minus 2/5. Use the right arrow to get out of the denominator, and then negative 2. Okay. And so now if we wanted to find the points of intersection, all we would have to do is plug in our x values into either one of these two functions to figure it out. So I'm going to go ahead and make a little room here so that we can go ahead and figure that out. Since they both share the same point, we'll take the easier function, which is g of x. So we'll say g of negative 2/5 and see what that is. Okay, and so that would be, make sure that we're doing, yes, so negative 24 over 5 and 15 plus 15, and plus 15 would be the same as, I believe it's 75 over 5. If I'm not correct, yeah, so let's see, this goes into that once, so the 2 remaining, yes. So now if we do that, 75 minus 24, you know, that should be, let's see, 75 minus 25 is 50, so we got one more than that. So that should give us 51. 51 over 5. Okay. And so that should be the first one. And so for the second one, we just plug in a negative 2 into g of x. And so that would be a negative 24 plus 15. And that would end up being a minus 9. So our 2 points here would be negative 2/5, 51 over 5, and the other one would be a negative 2, negative 9. So for these two graphs, that's where they would cross. And so now they're asking us for an ordered pair, so we need to make sure that we give them exactly what they want. So move this over slightly. Here's my first order pair, negative 2 divided by 5. And then the next one would be 51 divided by 5. And, oh, okay. Guess it didn't like that, so I'll go here with 51 divided by 5 like that. And then the comma. And then we'll go ahead and same thing again. And that would be negative 2, negative 9. All right, and so that concludes our example of the applications.